Hello and welcome to this video that models solving equations using square roots. They would be equations that have expressions where there are squares in them. Maybe you've seen things like this when you've used Pythagorean theorem to find sides of right triangles. Just some quick examples. Something like this is an example of an equation with a square in it that you could use the inverse operation of square rooting to solve. Similarly, something like this would also be an equation that has squaring in it that you could use square root to solve. This leads into a very important idea in Algebra 2 and pre-calculus when you deal with quadratics, but we're just going to be looking at sort of a basic skill here in terms of using the inverse of squaring, which is square rooting. Okay, so I'm going to take you through these steps and some examples in a second. It says here to isolate the expression being squared. And up here, the expression being squared would be x, and up here the expression being squared would be m minus 5. Okay, and it says undo the square by square rooting. That's great because it's the inverse. Okay, and then there's this little asterisk here I'll talk about in a second. There's a footnote to that, and then continue to isolate the variable if necessary. So getting back to this asterisk, we have to take a second here and make sure we understand this really big idea, and it's a subtle difference between these two questions here that you have to understand. People get them confused. It says, what is the square root of 9? And then there's a number that says, what number can I square and get 9? Okay? Well, these sound like they're very related, right? Because in this one you have the square root of 9, and here if you have some sense of how these equations work, say, well, I'm going to square root 9 in that problem. So, but let's understand something here. If we talk about this and say, what's the square root of 9? Well, that's just 3. Okay? Now, commensurately, here you'd say, okay, well, what number can I square and get 9? Well, people would say 3 squared is 9. But there's another piece to this that people miss, okay? And that's the fact that you could also square -3 and get 9. So really, you got to understand that here, this is the difference between simplifying and solving. Okay? This is an expression here that we simplify, and this is an equation here that we solve, and implied in that is an understanding that it's not what number can I square and get 9 when I go to solve that equation. It's really a what numbers. In fact, tell me all the numbers I can square and get 9 when you address this. Okay? So if we see this, that means that it's plus or minus 3 is the answer to this question, positive or -3. So you need to realize here that if you're going to be solving this equation with the inverse, the big idea here is when you go to square root and you're solving, you have to imply and remember that there are 2 possible solutions, one positive and one negative. So when we go back here to our steps, the big idea here with this asterisk, when you undo the square by square rooting, is do not forget the plus minus options in your solutions. Okay? So let's take a look at some examples here. Okay, and I'll do them. And again, the steps are written up here. Isolate the expression being squared. Undo the squaring by square rooting. And again, don't forget the plus minus when you do it. And continue to isolate the variable if necessary. So our directions here say, please solve the following equations, state null set when no real solution exists, and give exact answers. Okay, so we're not going to use our calculator and round any roots with decimals. We'll just use our knowledge of simplifying roots to give exact answers. Okay, so step 1 says to isolate the expression being squared here, so that's just the x. So I'll be able to do that by adding 10 to both sides. That'll give me x squared equals 22. And then undo the square by square rooting. Don't forget to do the plus minus. So I'll square root this side and that side and realize it's plus minus. So this becomes the square root of x squared is just x because they're inverse operations, plus or minus the square root of 22. Because 22's factors are just 2 and 11, I can't actually simplify that any further. So I in fact get these two answers here for the solution, x equals plus or minus the square root of 22. So moving on to the next example where it says the quantity r minus 5 squared minus 13 equals 22, equals 12. We see here when talking about step 1, it says isolate the expression being squared. Well, that's this r minus 5 is the expression being squared. So I will add 13 to both sides to isolate it. I'll get r minus 5 squared. The inverses cancel, equals 25. So then in step 2, where it says to undo the square by square rooting, I'll do that. And I will, in fact, remember to do the plus minus, okay, on the right side of the equation. And we get here that this squaring undoes that square rooting, so we're just left on the left side with r minus 5 equals plus or minus, and the square root of 25 is 5. So from there, it says to continue to isolate for the variable if necessary. I didn't need to do that in the previous problem. So I'm going to add 5 to both sides. Now this is where the writing can become a little bit awkward for a second. So I'll go here and go r equals. Now if you notice it says plus or minus 5 plus 5. Well, I'm actually going to write this term first and put the plus or minus term second. It'll be a little easier to understand. So I get plus 5 plus or minus 5. Okay, now this splits into two problems. It's r equals 5 plus 5 and r equals 5 minus 5. So we see that 5 plus 5 is 0, and 5 plus 5 is 10, and 5 minus 5 is 0. So there's two answers here. Notice it's not like my previous answer where it's like plus or minus the same thing. I, in fact, am getting, I'll write the answer up here, r equals 0 and r equals 10. They're my answers. Again, they are my answers because I can plug both of them back into the original problem and see that when I use the order of operations to simplify the left side, I'll in fact get 12. And you could actually do that on your calculator. Okay? So next example is a little bit interesting. It's a little different. So we have 3b squared plus 18 minus 12. We see here that the expression being squared is the b, not the 3b, but just the b. So I'm going to isolate that by subtracting 18 from both sides. I'm writing 3b squared equals negative 6. I'll continue to isolate that by dividing by 3. We'll write a little better, 3. And then that is going to give me b squared equals negative 2. And then when I go to now apply step 2, something interesting happens where it says to square root both sides. And don't forget your plus minus. We get b equals, and I'll hold off for 1 second and go to the calculator. But you probably see what's coming if you have some sense of square rooting negative values. So I'll do second square root of negative 2 and realize that that's non-real. This is an example of null set. You cannot square root a negative number and get a real answer. So we will say b is null set, which is done by this symbol. We're writing the words null set. Okay? So the answer to that question is that there is no answer. Okay? So, continuing on, um, we will take a look at solving this one. It says 4 times the quantity m plus 4 squared equals 12. Now, I just want to take a moment and touch on something here, because you probably have seen me do something in class or your teacher where they take this idea of m plus 4 squared and they say, oh, I'm supposed to square that. So that's actually going to be m plus 4 times m plus 4 and actually FOIL it all out, or even do the shortcut for it and come up with m squared plus 8m plus 16. And then even try and address that 4 times it in the problem. This is a bad idea. Okay, now if you think about what we're doing here, okay, and just sidebar for a second, is we're using inverses. We're not doing, we're undoing. Where it says minus 10, I'm adding 10 to go backwards. Where it says minus 13, I'm adding 13 to go backwards. Where it says plus 18, I'm subtracting 18 to go backwards. Where it says multiply by 3, I'm adding 3 to go back. I'm sorry, I'm dividing by 3 to go backwards. And where it says square in all these problems, I'm square rooting to go backwards. So I'm not actually going to try and square this expression, because that would be going forward. Okay? When we get into this idea of solve, a lot of times it involves going backwards. So you need to be mindful of that. And that's what's involved in these steps where it says isolate the expression being squared. Well, to do that, you use inverses. So where I'm multiplying by 4, I'm actually going to divide both sides by 4. And that's going to give me the quantity of m plus 4 squared equals 3. And then now that I have the m plus 4, which was the expression being squared, isolated, I can continue and square root both sides, which is step 2, but don't forget the plus minus. And that is going to leave me with m plus 4 equals plus or minus the square root of 3. Okay? Now, it says in step 3 to continue to isolate the variable if necessary. Well, I will by subtracting 4 from both sides. And again, a little bit of the awkward writing here. M, 4 minus 4 cancels, equals. The best way you could write this is the non-root part first. There are 2 terms here, actually. So I'm going to write the negative 4 and then the plus or minus root 3. Okay, and there's actually 2 numbers there. The first one is negative 4 plus the square root of 3. And the second one is negative 4 minus the square root of 3. Often we talk about the fact that this is 2 numbers. Kids make the mistake and say, oh, negative 4 is the first number and root 3 is the second number. That's not true. Okay? So we know that this is our answer. And again, we can actually just take a look at checking it on our calculator before I get out of here. And what am I going to do here? I'm going to hit second quit and clear out this last problem. And then I'm going to hit negative 4 plus second x squared, excuse me, I missed my plus sign, plus second x squared to bring up the square root, 3, right arrow, and I'm going to go store x. Okay? So although that brings up the decimal there, that's fine. It knows the exact value is negative 4 plus root 3. And I'm just going to punch that into the original problem, which if you see here, it said 4 times the quantity m plus 4 squared. So I've got 4 times the quantity, m plus 4, no big deal to use x because that's what I needed on my calculator, squared, and when I hit equals, I should be getting 12. And I, in fact, am supposed to get 12 in the equation. Now, I only checked the one answer. You can check the other, but for the sake of time, I think you get the point. Okay? So, again, this is the idea of solving equations using square roots. It appears in equations where there are squares. This is just kind of a basic outlook on dealing with these equations. And again, it leads to your idea of being able to manipulate bigger principles in dealing with quadratics. The big thing we want to realize that when we are square rooting, when we are solving, that there are 2 solutions. But if we're simplifying, it's just in fact going to be 1. So it's a little different in terms of how we use square root when we're simplifying versus when we're solving. So enjoy, work hard, practice.